Welcome back, friends. Today we're going to be discussing the relationship between pH, KH, and CO2. Let's get into it. First, let's define the terms. pH is the measure of hydrogen ions in the water. It's essentially how acidic or alkaline the water is. 0 to 7 is acidic, and 7 to 14 is alkaline, 7 being neutral. KH is carbonate hardness. It's a measure of how much carbonate and bicarbonate ions are in the water. And finally, CO2, carbon dioxide. It's a gas that's present in the atmosphere. In the atmosphere, its concentration is about 424 ppms as of this recording. The equilibrium between the atmospheric carbon dioxide and the carbon dioxide that dissolves in the water naturally is about 2 to 3 ppms. So this is the equation for the buffering action of KH. So we have carbon dioxide plus water produces H2CO3, which is carbonic acid. On the other side of the equation, we've got a hydrogen ion, and we've got hydrogen, carbon, 3 oxygens. This is a bicarbonate ion. So as we add CO2 into the aquarium, it increases the concentration of carbonic acid. The CO2 combines with the H2O to produce carbonic acid. If the carbonic acid increases, it also increases the loose hydrogen ions and carbonates. If there are free carbonates present, it combines with the loose hydrogen ions and they get converted back into carbonic acid. And this way, KH acts essentially as a pH buffer by preventing too many loose hydrogen ions. So now we know that CO2 and KH and pH are all balanced by that equation. So scientists have mapped out the values for all of the pH values and the KH values and the corresponding CO2 values. So if you have a neutral water with a KH of KH of 1, you've got a 3 ppm of CO2. If you've got neutral water and you've got a KH of 5, you've got, there's so many lines, it's hard to read this. You've got a CO2 concentration of 15 ppms. So people like to use this chart to get an idea of what their CO2 concentrations are for their aquatic plants. My current parameters are about 6.2, and I've got about a 2 KH, and it looks like 37.9. It's hard to read. 37.9 is the concentration, supposedly. I do have a nice yellowy green, lime green drop checker. But let's go into a little bit more detail about why this chart is inaccurate. So the reason that this chart's inaccurate is that there are other things happening in the water chemistry of your aquarium. That chart is created with pure H2O and nothing else. It's CO2, bicarbonate, and pure water. And that chart is accurate in those settings. But in our aquarium, we have many different chemical processes happening. We've got the whole nitrogen cycle happening. We've got different biological processes breaking down different chemicals and compounds. And some of those will influence the pH and carbonate hardness and everything. So that chart isn't exactly accurate. So if you want to measure the pH in your aquarium, if you want to measure the CO2 concentration in your aquarium, what you need to do is there's 2 main ways you can do it. The first way is you get a drop checker. And with a drop checker, it's got a little neutral fluid in it that will be Blue if the CO2 concentrations are low. If the CO2 concentrations are adequate for your plants, it'll be green. And if it's dangerous for your fish, it'll be yellow. And most people can use that roughly as a guide of how much CO2 concentration you have in your water. For people that want to get a little bit more advanced and want to know exactly how much CO2 you have in your water, you can, or to target, I should say, to target about 30 ppms. 30 ppm is the kind of the sweet spot for growing plants without killing your fish. So most aquarists that are using CO2 injection target about 30 ppm CO2. The way you do that is you take a measurement of your pH prior to your CO2 injection turning on in the morning. So you should have a nice blue drop checker, no CO2 being injected. You should have a nice neutral equilibrium with the atmosphere. And that'll be about 2 to 3 ppm within your water at that point. And you take a pH measurement of what is your natural pH of your aquarium without CO2 injection. Then you turn your CO2 injection on and you want to target a 1 to 1.2 drop in pH. That amount of drop in pH after you start injecting CO2 will be equivalent to approximately 30 ppm CO2. You don't want to go too high, you don't want to go too low, but that way it'll be a much more accurate guide of how much CO2 you actually have in your water. So why is this important? Why is it important to have a measurement of your KH, pH, and CO2? If you're growing plants, you want to target 30 ppm CO2 concentrations in your water with CO2 injection. It's going to help your plants grow without killing your fish. There will be an upper limit to how much CO2 you can put in your aquarium without causing stress to your fish. And the general rule of thumb is about 30 ppm. The primary compound that plants are made of is carbon, and they get that carbon from carbon dioxide. Since they're not in the atmosphere has 424 ppm concentration of CO2. So plants that are in the air can take tons and tons of carbon and grow incredibly quickly. But in an aquarium, the natural equilibrium of carbon dioxide within the water is only 2 to 3 ppm. That's 10 times less. That's 100 times less. That's 100 times less CO2 in the water with a natural equilibrium. So plants are going to grow way, way slower. If you want to boost the growth of your aquarium plants, you need to inject CO2 to give them a little bit more carbon. CO2 injection, your target's going to be 30 ppms. So this is why it's important we know how much carbon dioxide we're putting in our water to help our plants grow without killing our fish. If you want to learn more about keeping your aquarium healthy and thriving, watch this video over here. In conclusion, understanding how to measure and adjust your CO2 levels in your aquarium is important to keep your fish and plants healthy. Remember to use the right approach to estimating CO2 levels and always observe your livestock and plants to ensure they're adapting well to the changes. With these tips, you can create the ideal environment for your fish and plants to thrive. Thanks for watching. See you next time.